Next we are having the chain rule. So chain rule, we are using it for certain conditions where we cannot differentiate it directly. So first of all, if you check this equation, right, this function 3x plus 1 the whole raised to 4, we don't know how to expand the power 4, right? So we cannot take the derivative of this one directly. So in order to take the derivative, we'll be using the chain rule here. First of all, I will discuss how to solve this question so you can understand the formula after that. So we can take whatever it's inside the power as u, right? So u, it will be equal to 3x plus 1, right? So our u will be 3x plus 1 the whole raised to 4. So this function can be written as y is equal to u raised to 4. So now we have to differentiate this y with respect to u. We cannot do dy by dx. We cannot differentiate it with respect to x directly. So first what we'll be doing means we can write it as dy by du. Then this du we can differentiate it with respect to dx. So if you check here, our u is 3x plus 1, whatever is inside the power. So the derivative will be du by dx. It will be equal to, so derivative of 3x, it will be equal to 3, because derivative of x is 1 and 3 multiplied with 1 will be 3, plus derivative of 1 is a constant, so it will be 0, so it will be 3 only. So du by dx is 3 and y is equal to u raised to 4. Now we'll be taking the derivative with respect to u here. Instead of x, we'll be taking it with respect to u. So it will be first the power, then u raised to 4 minus 1 will be 3. So the derivative of this one will be 4u cubed. This part is 4u cubed multiplied with 3. Then instead of u, what we'll be doing means we should replace it by the real function. So it will be 12. Then instead of u, it will be, what is our u here? 3x plus 1 and raised to 3. So this is the final answer which we need. So this way we can apply the chain rule. When we cannot differentiate y with respect to x, what we can do means we can add an intermediate like variable like u or w, anything like that. So first dy by du will be doing, and then we'll be doing du by dx. So actually if you check here, du will get cancelled and finally you'll be getting the same thing only, dy by dx, but we are doing it in separate steps in order to make it easy for the calculations. Sometimes you cannot do certain steps without the chain rule, so you have to use it in certain conditions. Here we are having another question for chain rule here. We cannot directly apply the derivative formula here, y is equal to sine of cos of x by 2. So first of all, what we'll be doing means whatever is inside the angle part of sine, we'll be writing it as a variable. Let's say w here. So y is equal to sine w. So here our w is cos x by 2. So now we have to take the derivative of this with respect to w. So it will be, if you see, the derivative of sine is cos, and we will be writing the same variable here itself. So it will be cos w. So next we have to find the derivative of w with respect to x. But if you see here also we cannot directly take the derivative of cos, right? Because it's not cos x, it's cos x by 2. So what we'll be doing means instead of x by 2, we'll be taking it as another constant u, where u is equal to x by 2. So now we have to find the derivative of w with respect to u. So what is the derivative of cos? It is minus sine. So now going to the last part, now we have to find the derivative of u with respect to x. Here we can take the derivative directly, right? Because just there's a constant with x, so it will be half, and the derivative of x will be 1, so half into 1 will be half. So we are having three different parts here. So now we can arrange it like this: dy by dx, we can find it like this. First, dy by dw multiplied with dw by du, the second one multiplied with du by dx. So if you see here dw, dw, du, they will get cancelled, just you'll be left with dy by dx. So now we have to just do the multiplication part. So dy by dw first, so it will be cos w, this one. Then dw by du, it's minus sine u. Then du by dx, it's half. So it will be instead of w, we can write it as, what is our w here? It's cos u, and instead of u, you can write it as x by 2. So our cos w will be cos, instead of w it's cos u, but instead of u it's x by 2. So instead of cos w, you can write it as cos of cos x by 2, cos x by 2. Then minus sine u we are having, we can take the minus sign outside. So what is the u here? Our u is x by 2. So instead of sine u, you can write it as sine x by 2, sine x by 2. This thing is an angle, and the whole thing is divided by du by dx, our half, right? So it's 2. So this is the final required answer: minus cos of cos x by 2 multiplied with sine x by 2, the whole thing divided by 2. So like this you can apply the chain rule here. So here we are having another question for the chain rule. So we have to differentiate 2 root of cot the whole x squared. So this one we cannot differentiate it directly. So first of all, if you check, we can write y as y is equal to 2 root, so whatever it's there inside the root, we can write it as u. So we have to find out du dy by du. So 2, so what is the derivative of root u? It is 1 by 2 root u, right? This is a general formula you can apply here, because lot of questions have this formula used. So when we are having root x, the derivative of it will be 1 by 2 root x. So if you check, 2 will get cancelled, we'll be just left out with root u. So our root, if you check, our u we have specified as cot of x squared, right? So whatever it's there inside the inside the root, we have specified that as the u variable here. So but we cannot take the differentiation of u with respect to x directly, because it is cot of x squared, not cot x. So what we'll be doing means, we can specify another variable here as, let's say, s here. So s is equal to x squared. So we have to find the derivative of cot s. So we have to do the du by ds, right, with respect to the variable s here. So cot of s, what is the derivative of cot of any variable? So it will be minus cosec squared s, the same variable. Cot derivative is minus cosec squared. So finally we are having s here, and we'll be taking the derivative with respect to x. So what is the derivative of x squared? It will be the power multiplied with the variable raised to 2 minus 1, it will be 1. So it will be 2x itself. So now we can apply this formula: dy by dx is equal to the first one, dy by du multiplied with du by ds and multiplied with ds by dx. So if you check, it will be, our derivative will be y dash will be equal to 1 by root u, 1 by root u, and multiplied with minus cosec squared s multiplied with 2x. So now what we can do means, instead of s we can put it as x squared, and instead of u we can write it as cot s. We cannot write it as cot s, right? So it will be cot x squared, right? Instead of s you can put it as x squared. So it will be 1 by root u, our u is cot x squared, cot x squared, and this will be the numerator, you can write it directly upside, so it will be minus 2x, this one, multiplied with cosec squared of our s is x squared, x squared. So this is the answer for the derivative of this function.